Welcome to this new tutorial. In this tutorial, we are going to learn about how we can create a Hello World smart contract in Solana blockchain, and we are going to use the Rust programming language for this. So as a first step for this tutorial, we need to open the VS Code, which is already open by now. So now I'm going to just open the terminal from the VS Code so that I can work more on that. And if you're watching this video on YouTube, then you will be finding a link to this particular lab in the description. So go and check out that link so that you can do this practical lab hands-on, and that's the best way to get the complete out of this particular lab and this tutorial video. So to start off with, you can also check this particular lab that is linked here in step 2 of this manual. That this is about how you can install a Solana blockchain network for your local work, and you can do that as well. It's not a prerequisite. We have already installed this for this particular lab, so you can carry forward with this lab. So in the next step, we will check that if Solana is installed successfully. So as you can see, the Solana version is here. And now we will move forward to checking the cargo version. And as you can see, it's installed correctly here. The version is quite visible. So let's move forward with the next step. So now we will be creating a key pair, which is basically we are creating a wallet or an account in the Solana blockchain so that we can do some transactions, because in this particular blockchain, everything works through transactions. So we are creating a new key pair by running this Solana keygen new. And after that, it will ask you to give a paraphrase. So you can just skip this step by keeping it empty and hitting enter. So now a new key pair has been written in this particular location, and now we can move forward to starting our blockchain. So we can run this Solana test validator, and if we hit enter, you can see it will be initializing a test ledger, and now you can see the blocks are getting added and the blockchain has started. So now as a next step, we are going to configure this blockchain to have localhost in its RPC port. As you can see, we have modified the RPC URL and the WebSocket URL to localhost 8899 and 8900. So with all this done, now the blockchain is ready for work. So we can either make an airdrop or we can check balance in the blockchain to see if we have any souls or not. So we can check by running this Solana balance command. And you can see we are already topped up with a lot of souls. So if you want, you can do this Solana airdrop command as well. It will just add up to the number of souls. So we have just taken 2 souls, and as you can see, it has increased by 2. So now we come to the next step, that is creating the project for our smart contract. So we are going to build a cargo library. So it's basically we are going to write it in Rust, and we are going to create a library which will be compiled into BPF bytecode, and it will be saved in the .so format. So now we will be creating this library. So we are going to run this cargo init hello world command. Hello world is the name of our project, and this $lib makes that we are going to import is important because we are going to make it a library. So let's hit enter. So we have created the library package. And now we will be coming inside this library package so that we can also add the Solana program into it. And we are going to run this cargo add Solana program command to add the Solana program into it. So now we are done. So now let's move to the file explorer mode, and you can see we have this package here, hello world. And inside this package, we will be finding cargo.toml and cargo.log files. So if you have done some development in Node.js, then you can relate it to it as like package.json and package.log file. So it has all the dependencies and the versions in the cargo.log. So now we are going to add this particular dependency that we are seeing in step 14. So let's see what it is. So basically we are just adding our library into this particular dependency section. And we have given the name, and we have given the crate type as well, cdylib. And now we can just save this particular file. And now as we have saved it, we are going to head into this source folder. This is the src folder. In it, we have the lib.rs file. So basically this is the main file for our smart contract, and now it has some predefined code. We won't need that. So let's just clean it up first up. And now we are going to add some code into it. So this is the first bit of code that I'm adding here. So this is some sort of a header file. You can think about it. It just gives the dependencies. It will just tell us about that what the smart contract is about. It is going to open the and it is going to give you the details about the account info it is taking. It is also defining the entry points, and we'll talk about these in more detail. But first up, let's just complete this program. So we're just pasting the code here. So this is defining the or declaring the entry point to this particular smart contracts and smart contract. So that means whenever it will be in the blockchain, if you see something like hello world, from that the smart contract will be invoked, and after that the functionalities will work. So it's like, how will a normal function be called? You can relate to it in that way as well. And this is the main function of the smart contract, which is hello world, the name of the smart contract. And after that it has some things, and we'll talk about it more, but let's first compile this smart contract. So to compile, we are going to use cargo build BPF. As I've already mentioned, we are going to build it in the BPF format, and I'm doing the compilation first because it will take around 10 to 12 minutes. So you need to keep that amount of time, because firstly it will be installing a lot of dependencies and downloading the dependencies, then it will install them and so on and so forth. So as you can see, there was some 350 MBs of download first, and now it appears that it is blank. But basically what's happening here is that here it is just getting itself ready to download the necessary dependencies, the other dependencies that are here. So now let's talk a bit more about the program, the time the dependencies get downloaded and installed. So basically this is the starting of the program. So it defines that what are the major parameters or the things that are needed in the program. Like this is the account info which is needed. So it has the account info of the blockchain wallet. After that, we have defined entry point macro, and in the entry point, we are also binding the program result. So what basically this means is that to the entry point, the result of the program is also going to be passed through, and then we get the pub key, which is the public key as well. And after that, we have MSG. This is another macro for printing something into the blockchain program. So this is about the message as well. So now if we move on to the entry point, so this is basically the entry point where the smart contract, you can say, will be invoked. And after that, we will be starting this function. Like this is the public function. So pub fn means public function. If you have done some Rust coding, this would be familiar to you. And then we name the function as hello world. And after that, as we pass parameters to a function, these are certain parameters like the program ID. So that means the program's public key we are passing. Then we are passing the accounts in the blockchain, and then we are passing some instruction data to the program. And after that, this message macro is nothing. As I've already mentioned, it is going to help in printing the data into the message into the blockchain. And after that, to close the program, it's like okay. So you can think of it like a return statement as well. So this was about our basic hello world program. And now you can see there is some fetching that is going on here. So it's resolving the deltas. That means it's just opening the packages, and after that it will install. So we will skip this installation part. So with this, as you can see, our program is compiled successfully, and you can see a few warnings like that. So you can ignore that. It won't be causing any issue. So now after the program is compiled, you can see there is a new target directory that has been created here. And inside that, we have a deploy directory, which is having this hello world.so file. And basically these are, and we have this release file, release folder as well, which is having the smart contract code as well. So just trying to open it out. And inside this build, we will be having the folders here. So here in the deploy directory, we will be having a deploy directory. And inside this is the hello world.so. This is the smart contract file. And this is the hello world key pair file as well. So these are basically the two files that are going to be needed when we are going to deploy this program. And after the deployment as well, we will be getting a ABI code, and that ABI code is going, and basically we have got this ABI code here. And after the deployment, we will be getting a program ID for this particular program. So let's just deploy it now. So as you can see, it got deployed and it does not take too long. So after that, we have got this program ID. So this is the ID of that particular smart contract program that is deployed in the blockchain. And you can just check about the details of this program to confirm that the program is deployed successfully. So let's just paste this program ID into the Solana program show command. And you can do this with any other program's program ID to check the details about that particular program. So here you get the program ID, the owner, and you also get the address in the blockchain, and you get some balance that has been needed for this deployment and the data length. So this was about deploying a smart contract, a hello world smart contract. And you can definitely, after this, you can work with this smart contract into your D app as well. So basically, after compilation, it is converted into a ABI, application binary interface. So basically, that's the interface which helps in working, which is the interface that helps in the communication between the smart contract and the D app or the application that you have built. So if you have watched this video on YouTube, do check out the link in the description to this particular lab. You can go to the lab and perform this by your own, and you will be getting more insights about it. You can go through all these folders and files that will definitely help you a lot in understanding these things.